Okay, today we're going to be talking a little bit more about probability. Remember, probability is really the chance of something happening, and probability can be expressed as a decimal, a percent, or as a fraction. But probability goes from anywhere from 0, meaning it will never happen, it's impossible, to 1 or 100%, meaning it will always happen. Today we want to look at sample space as one of the vocabulary words. And again, it is all possibilities of a given experiment. So if I give you rolling of a number cube, what would be the sample space? Well, the sample space would be 0, 1, 0. There is no 0 on a number cube. It's only 1, 2, 3, 4, 5, or 6. There's nothing else you could possibly get on a die. Those are the only 6 numbers. What about if I say flipping a coin? What would be the sample space? What is any or what's all possible things I could ever hope to get if I flipped a coin? Right, exactly. It would be heads or tails. Those are the only 2 things I could ever hope to get. Now, an event, when someone talks about an event, it's really a collection of outcomes of any experiment that you do. So let's just say I have an experiment where I'm going to, well, how about roll a number cube? And with that rolling of a number cube, let's say I'm going to roll it 6 times. What would be all of my possible outcomes? Okay, so we're going to roll this die 6 times to see what we get. First roll, I get a 2. Roll it again, I get a 4. Roll it again, I get a 2. Roll it again, I get another 2. Roll it again, I get a 5. And one more time, I get a 3. Okay, that was my experiment. Now we're going to record what we found. So we rolled that die and we got a 2. Then we got a 4. We got a 2, a 2, a 5, and a 3. That's my collection of my outcomes from my experiment. Now we're going to go ahead and actually look at finding the probability. If I give you this table and I roll a die and I know that my sample space is only 1, 2, 3, 4, 5, and 6, but I roll it a whole bunch of times and I record how many 1s I get, how many 2s, 3s, 4s, 5s, and 6s, and then I say, what is the probability of getting a 2? And just so you know, this is the mathematical notation, and that P stands for probability. How I read this is what is the probability of, and then inside I see the 2. What's the probability of a 2? Well, I told you probability can be a ratio, a decimal, or a percent. And for numbers 1 to 8 tonight, I want you to give it to me as a ratio. So the first thing we're going to do is tell me how many times did what I want occur? Well, in this case, a 2, I got that 4 times. So my numerator is going to be a 4. Now it's going to be over my total outcomes. How do I find those total outcomes? Well, I need to add up all of those numbers to see how many times did I roll it to begin with. Well, if I go ahead and count those all up, I should get 24. Now, step 2, we're going to reduce it or simplify it if I can. And I do know 4 goes into 4 and 4 goes into 24, and that's going to give me 1 out of 6. So my probability of getting a 2, if I rolled that one more time, is only 1 out of 6 chance. Do I think I'm going to get a 2? Doesn't mean necessarily I will, but what is the probability I would get that 2? So let's look at that next one. Next question says, what's the probability of, and then that symbol says greater than or equal to 5. Well, the only numbers that are greater than or equal to 5 would be 5 or 6. So that's what I'm asking. What's the chance I get a 5 or a 6? If I was to roll this one more time, what's the chance I get a 5 or a 6? Well, what is the number of times that it occurred? Well, I got 1 plus 2. That would give me 3. So my number of times I got what I want right now is 3. Out of how many times altogether? Again, we rolled that 24 times. Can I reduce it? Yes, 3 goes into 3 and 3 goes into 24. That would give me 1 out of 8. I have a 1 out of 8 chance of getting a 4 or a 5 or a 6 if I roll that die one more time. Now look at the next one. It says, what's the probability that I get a 0? Well, how many zeros are even on my die? 0 out of 24, which means the chance that I would get a 0 on my next roll is absolutely impossible. It's 0. Then looking at the next one, what's the probability I get less than 4? Well, the only numbers that are less than 4 are 3, 2, and 1. So how many 3, 2s, or 1s do I have right now? Well, I can see 5, 9 plus 6 is 15. So far, I've gotten 15 things that are less than 4 out of 24 altogether. Can I reduce it? Absolutely, because 3 goes into both. That gives me the probability of 5 out of 8. I have a 5 out of 8 chance of getting something less than 4 on my next roll. And last, a 3 or a 4. How many 3s or 4s did I get so far? Well, I have a total of 12 of those. So 12 out of 24. When I go ahead to reduce that, I should get 1 out of 2. So what's the chance I get a 3 or a 4 on the next roll? 1 out of 2 chance. So now let's look at what if I gave you a chart. And this time I give you the outcomes. There's only 1, 2, 3, 4, and 5. Those are the only numbers possible. But this time I actually give you the probability. And if you go ahead and look at that, none of these are a great chance of actually happening. If you think of 0.024, that's only 2.4% chance. That's horrible. In fact, the best chance I have is right here for number 4 is 0.341. I only have a 34.1% chance of getting a number 4. Still not very good, but better than any of the rest. Now, when I add all of those totals up, though, those decimals, I should get 1 because this should all add up to 100%. So when I go ahead to find out the percentage of, what's the chance I can get a 1 or a 2? What's the probability of a 1 or a 2? In those steps, I'm telling you first, add the probability. If I gave it to you, add the probability of the ones you want, which are right here. So 0.024 plus the 0.327. When I add those up, I should get 0.351. Now in step 2, I'm telling you for numbers 9 to 13, I want you to actually change that decimal to a percent. We did ratios for numbers 1 to 8. You're getting me a decimal right now. So now change that into a percent so I can see that a probability can be any of those 3 representations. So that would be 35.1% chance of getting a 1 or a 2. Now looking at B, it says what's the probability of getting a 2, 3, or 4? Well, that means I need to add up a 2, a 3, or a 4, because that's what I want to happen, and those are the probabilities of each of them. So when I go ahead and add those up, you should come up with, see, 5, 9, 7, 0.794, which would be what percent? Multiply that by 100, 79.4%. Oops, I didn't mean to move that on you. Which is a pretty good chance that I can roll a 2, 3, or 4 on the next roll. So that's our introduction to probability. We're going to continue to work on these statistics. So if you have any questions, make sure to write them down and bring them to